Oye. This is assignment for day one, the assignment for day one on data analysis, dot plots, and stem and leaf plots. We're going to start with the recent ones. A lot of you guys had questions on that, and we need to review unit measurements a little more. So speaking of which, a snail moved 8 millimeters in 1 minute. How many centimeters did it move? So this one's rather easy. Like I said, you can always start with just writing out your units to the left so you don't have to really worry about them when you're working with the raw numbers. So centimeters to millimeters. I see two different units here, centimeters and millimeters. So some conversion is gonna have to happen. I'll probably hang up a unit conversion chart in the room for now, and then we can just go from there. So we don't have to bog ourselves down too much with the specifics. So from that chart, you'll be able to see that 1 centimeter is equivalent to 10 millimeters, right? And they gave us, the snail moved 8 millimeters in 1 minute. This is kind of irrelevant information. Just kind of block that out of your head. You don't need the 1 minute right now. It's just asking how many centimeters did it move. So that'll be our X. So yeah. And one thing one of you pointed out yesterday is that we could just do a cross multiplication or a butterfly, hash this out using the butterfly method. So we're just going to say 10x is equal to 8. And I got that by saying 10 times x is equal to 8 times 1. That's the butterfly. Another way to write this, and this might be a little more intuitive for you guys, is just to put a parenthesis around the x so you can understand that you're saying 10 times x. Okay, so now we want to get x by itself using the butterfly method. So we're going to divide. What's the opposite of multiplication so we can get x by itself? It's division. So you want to divide by 10 here. And yeah, and then do the same over here. That'll cancel out. And now x will be equal to whatever 8 divided by 10 is. Remember the rule. I'm running out of space. I'm just going to move up here. Top in, bottom out. 10, how many times does 10 go into 8? It does not. So behind every number there is an implied what? Decimal. Okay, and behind that decimal there is a 0. How many times does 10 go into 80? Oh, before I do that, let me just move my decimal up here. That's the rule. Whenever you divide by using a decimal in division, you just move it up above the bracket or the hat. So yeah, so 10 goes into 80 8 times. 8 times 10 is 80. Subtract, finish it out, and you're done. X is equal to 0.8 centimeters. That's your answer. The next one's pretty simple too. What is the area of a parallelogram in square inches? Okay, that's an important thing. And guys, I know I was teaching you guys to use like the bullet and then the arrow. You're free to keep doing that, but just for the sake of time, I want to keep these videos a bit compact. So I'm doing this in my head. So I know I see square inches, I see 3.4 inches, 6 inches, I see height, I see base. Okay, so if the base of a parallelogram is 3.4 inches and the height is 6 inches, what is the area? So find area. And the equation to get the area of a parallelogram, area equals base, or rather, area equals length times width. So I'll make that a bit more clear. Yeah, area equals length times width. Another way to look at this is base times the height. right? So what is 3.4 times 6? So I say 6 times 4 is 24. 6 times 3 is 18, 19, 20. There's an implied decimal over here. I move it up one because there's only one decimal in the whole problem. I know it's a bit tough to see, but that's a 20.4. So 20.4 inches squared, because we just multiplied inches by inches again. So that'll make inches squared. Okay. Now we're just gonna do 3 and 4. A lot of you guys finished this in class, so I'll just kind of speed run through this. There are 10 bear cubs at a refugee center. The cubs are bottled, fed 3 times each day. The number of ounces each cub is fed during a feeding is given below. 32, 36, 32, etc. Create a dot plot. That's easy. Okay. How many times do I see 32? 1. I see it twice. So how many dots do I put over 32? 1, 2. 33. How many dots do I see? 0. Skip it. 34. How many do I see? 1. All right. 1 dot over 34. 35. 36. I see 3. 1, 2, 3. How about 37? No. 38. I see 2. 1, 2. And 40. Sorry, 39 I can skip because there's no 39 up here. 40, I see it twice. 1, 2. Yeah. So now we just need to create a stem and leaf plot. And creating a dot plot before your stem and leaf plot is actually very helpful. Last video, guys, I said to create something called a frequency chart. And I can probably flip to where it was in my notes here. One moment. Okay, I said this frequency table, it helps you make dot plots. This is definitely helpful, but not necessary. If you want to kind of just forget about this and do it the way we were doing it in class, which seems to be a bit more efficient and less time consuming, just cross the numbers out as you go. And if you miss one, you can always just go back and add another dot. You don't have to make a whole frequency table, especially when we're also dealing with stem and leaf plots. I don't want you guys to get confused between the two. So let's go ahead and create the stem and leaf plot. We used the numbers up here to make the dot plot. Now we're going to use the dot plot to create the stem and leaf plot, which is simple enough. So here's my stem. Here's my leaf. Right, and then I say my lowest digit on here is 30, 30, 40, 40, 3. I see 3 because all I see are 30s and 40s, right? My lowest number is going to be 32. I see that twice, so I'll put 32 twice. See that? 33, I do not see. 34, I have that once. See how this is helping you? This is telling you not only what number to put down, in this case 6, but how many times to put it down, in this case 3. So 6, 6, 6. 37 is blank, 38 happens twice. 40, so I have to come down here, add my 4, and yeah, and 40 happens twice, so 2 zeros here. And hopefully that makes sense, yeah? All right, now it says, what percentage of the cubs are fed exactly? 36 ounces each feeding. You guys were doing well on this in class. I'm not going to go over that one. That can be a homework assignment if you want. What fraction of the cubs are fed less than 36? So yeah, I'll end that one there. One last one on this one, guys. Yeah, so the one on the bottom here, it says on average, number 9, 1 out of every 5 people prefer winter over summer. If 45 people are asked which they prefer, set up and solve a proportion to find how many people you would expect to prefer winter. So enter the answer. Okay, so what I see so far, I see winter, I see summer, I see 1 out of every 5 people. prefer winter over summer. So there are going to be two things. I see winter. Here's another bit of like extraneous information that you guys don't need. Just block summer out of your head. I see a winter and I see a total. And this is one person out of every 5 prefers winter, right? And they're asking us to find how many people you would expect to prefer winter. Ratios are a multiplicative relationship, so I go over and they said, okay, oh, and also, guys, what else has been helping you guys has just been differentiating by using the ratio and the real deal side of things, right? So the ratio, it says on average, so I see the word average, that makes me think of ratio, right? Percentage, average, anything like that. So 1 out of every 5 people prefer winter over summer. 45 people, that looks like a real deal type of thing. So I didn't see any extra information denoting like a ratio. So 45 people are asked which they prefer. So I see 45 people total down here. See why I ignored summer? Summer is not really relevant in this problem, just like the time up here was not relevant, the 1 minute. Sometimes you could just cross out the irrelevant information that you don't need right now. And yeah, so all they're asking us is just to make an equation to solve for x. And that's exactly what we'll put in here, this x. So what does x equal? Well, let's just start with my favorite one, scale factoring. It's the easiest one. I'll erase this for clarity. How many times does 5 go into 45? Excuse me. So 5 goes into 45, a sum total of 9 times. And what we do to the bottom, we must also do to the tops. So what's 1 times 9? 1 times 9 is going to be 9. So x is equal to 9. Alrighty.